I'm a PC, and today I'm making another tutorial for you guys. So in today's tutorial we're going to talk about some basic variables. If you don't know what a variable is, variables are things that will store data for you. So a very basic variable that's used in a lot of different games would be score. So if you have a score variable, the advantage of having it in a variable is that you can use it in different places and add to it, take away from it, and the value for a score is just stored in one place. So today we're going to talk about the 8 most basic variables called in Java, or types of variables I should say, in Java, and they're called primitive data types. So there's 8: byte, short, integer, long, float, double, boolean, and char. So that's 8. Now the first one to talk about are the ones that can only store whole numbers. So there are 4 of them, and the difference between the 4 are how much data they can store. So the one that can store the least data is byte. These are all stored in binary code, so in a series of zeros and ones, and byte can be stored in 8 digits of binary code. So that is 2 to the 8th power amount of values, so 256. So for that reason, you can go from -128 to 127. So 120 below 0, 127 above 0, and 0, 256. That's how the coding works. And so whenever you have a value between -128 and 127 and you use byte, you save a lot of space as compared to using those larger ones. So that same concept works for the larger ones as well. So short stores a range of 2 to the 16th different values. Integer is 2 to the 32nd different values. And then long, the largest one, can store 2 to the 64th different values. That's a lot of values. That's a range of 18 quintillion different values. That's 18 zeros. That's pretty major. So those are the first 4 different data types. And the next 2 are float and double. Float and double also store numbers, only with float and double they can store decimals. We'll start with float because it can store less decimals. Now it's hard to say how many decimals it can store because it depends on how many significant figures the number is. But from what I understand, float ranges from 30 to 40 decimals, and double, the next largest one, can store over 300 decimals. And for as far as storage goes, a float takes up the same amount of space as an integer, so 32 different digits in binary code, and double stores the same amount as long, so 64 digits. So that's 6 of them out of the way right there. And so now next one we're going to talk about is char. Char stores characters. It takes up the same amount of space as a short. So that's 16 different digits. Now char, you can just simply set it equal to 1 and only 1 character. So that could be A, B, C, any one of those, or space, or slash, or any character that you can type on a keyboard can be stored in a char. Next one is boolean. Boolean is extremely efficient for as far as data storage goes because it only takes up 1 digit in binary code because it can only be true or false. That's all. Now this sounds pretty useless at first, but in games or anything really, you'll see that you'll be using boolean over and over again for things that don't really matter, just true or false. For instance, in some games, they might have some of those being daytime and some of those being nighttime. The computer will ask, okay, is day or night? That's just true or false, day or night. Those are situations where you use boolean variables. So there's 8 different primitive data types. Stick around for the tutorial and we'll learn how to use them. So to start off, let's save it. I'm going to save it as primitive data types.java. You can either put .java here or select it in the drop down menu, but I'm going to put down all files. So now type down public class primitive data. All the code goes in these brackets, and make sure that this name right up here matches. Now we're going to start our main method. So you're still not at the point where you have to know what this part means, but just memorize it and know that's the main method, and you need the main method to start each program. Okay, so now we're going to make a series of variables. First variable I'm going to make is byte b equals 5. Alright, so semicolon is necessary after every statement. We have to do it in the after the println method, like we did the hello world program. When you're making variables, it's the same content. First start at the type of variable, what you want to name the variable, and the value you're going to assign to the variable. So we're saying the type of variable is a byte, naming the variable is going to be b, and it's going to equal 5. So we're going to represent it from now on as b, and whenever we say b, the computer's going to know that b is a byte, so it needs to store 8 digits of a binary code, and it needs to be set equal to 5. Okay? And we're going to set a little comment after this. Remember, comments do not affect the code at all. I'm going to put down the range of a byte. Byte can range between -128 and 127. Now we're going to go on to make our next one and call it short s, we set equal to 3000. Notice that if we try to set byte to 3000, we would get an error because it's not within this range, but the range of short is higher. So again, type name the value we're going to assign to that. Put down the comment here, give you the range of short. Next is int, which is the type, I, which is what we're going to name it, and it's equal to 2 billion, because it has a pretty long range. If we try to set short equal to 2 billion, it wouldn't work because 2 billion is not within short's range. Okay, and another thing I want you to notice is that I put out int here, but here I put an integer. When I say integer, it means the same thing. The only reason I had to put int here is because they figured integer would take too long to write, so they just have you put down int when you're coding, because you're going to be using it a lot, and those extra 4 letters will save you time. Alright, now next one above integer is long L, and you can make it pretty long. There we go, that's long. So that is really big. You can make an long, very long. Alright, so those are the first 4 types I talked about in the abstract. Those could all deal with only whole numbers, and now we're going to move on to the ones that can deal with decimals. First of which is float, call it float f, is equal to 3.14. And this isn't, we wouldn't be able to set I or L or any of these equal to 3.14 because it's decimal point. Because only float and double can be decimal. For the description, numbers can be decimals. And go up to 30 or 40 decimal points. And it's saying out that as a. Alright. Now double D equals, I'm not exactly sure how many decimal points you can have, but you can have a lot, so I'm just gonna, there you go. Those are our 2 decimal ones that contain decimals, and the last 2 are kind of unique. we're going to start with char. Char can be set equal to any one character. So make sure, if we're only putting one character, make sure you put the, instead of apostrophe, it's only with a single apostrophe rather than double. So this one, not that one. That's what you use when you're only using one character. Last one, this is our most space efficient one. It's called Boolean. Why they decided to not shorten this one, I don't know. Char is actually called character, I forgot to mention. So the ones that have, whose true names are longer than the names in the programming is char and int. And Boolean they decided to shorten, I don't know why. Let's call it bow. The reason I call it bow rather than b is because we already called byte b and I don't want to confuse anything. Equal to. Okay, so now our 8 variables. Now let's print them all out. So I'm going to say system.out.print. Start with byte. So this is print out byte with semicolon, and I put space there. Just print out byte with the semicolon, and then I put down b. So it'll print out byte, and it'll just print that out because that's in parentheses, or abbreviation, sorry. And then when you put down b without abbreviations, it'll look what equal to 5, and it'll just print out 5. And the same will happen, let's put it down like that, plus s. One thing I want to do here is that if we just print out like this, it'll show one line one after another. We don't want to do that. I want this to show up on the next. So there's a symbol you can type down when you want to skip a line. That's backward slash. Whenever you type this down and it's in abbreviations, it'll skip a line. Next one's integer. So we want this one to skip a line as well. Slash n long. That's the last of them. Now, say we're running out of space here. You can just click enter and go on the next line, and it won't affect it. The only thing that ends statements is the semicolon. And so if you skip lines, it doesn't matter. So we're going to skip line for next one is float, and we want to skip another line in order to organize it. So we're just going to put 2/n. Another /n because we want to skip another line. Char and last but not least, Boolean /n Boolean plus b. Okay, so with the semicolon there, this is the end of the statement. Now it should print that out. Make sure to save. Alright, switch over to command prompt. Make sure it's in the correct folder. Now we're going to type down, now we're going to compile it. So Java C, primitive data types .java. Alright, if we get an error, now don't panic because I predicted this. So what it's saying is, it says this number is too large, and we say, well, it's long, and that's the bounds of the long, so why doesn't it work? Whenever you're writing down code, it'll store the numbers in memory before it's actually set equal to a variable, and by default it sets it in memory equal to an integer. So 5 is actually set to an integer before it's set to b or byte, and 3000 is set an integer before it's set to short. And this one's an integer, but that doesn't matter because it stays an integer. But this one is set to an integer by default, and then it exceeds the amount and then doesn't know what to do. So we want to tell the compiler that it's a long, and we want it to be stored as a long. So the way you do that is put an L down. The same works for the decimal ones. So in order to state that this is a float, we want to be stored in memory as a float, have an F, and this one, put down D, so it's because it's being stored as double. Alright, I'll save it, and now when we compile it again, you can press the arrows in order to do the previous one, by the way. That's a nice little trick. Compile it again, should compile with no error. Perfect. So primitive, Java primitive. Fingers crossed. This is exactly what I want to happen. So we got, it says byte is 5, which it is. Byte is 5, and it says short is 3000, which it is. Short is 3000. Integer is, was that 2 billion? Yes, it is. And right here it says long, and it says without a semicolon. That means I probably made a typo, which I did. Gotta put that. All of these match. Then now you know how to work with primitive data types. Whenever you're working with numbers, you should know which primitive data type you want to set equal to. Now we're going to move on to the challenge and see if you really understand this. So for today's challenge, download this file right here. It's called primtest.jar, and I have a download link in the description. And then run it. This is a program that I made with Java. By the end of the series, we'll make them too. But the point of this one is to help you understand the difference between these different primitive types. So I'll give you a number here. This is -93, and you gotta put down which one fits best. So I'm gonna put down byte because that's in the range of the byte, and correct. And that one's also a byte, but let's say if I put short, I'll tell you to put it wrong, and it'll keep a track record of how well you're doing. So if you manage to get these right pretty easily, then you've got a good understanding of these primitive data types, and it'll help you in the future. So just practice with this. That's the challenge. So that's the end of this tutorial. Thank you for watching. If you found this helpful, please rate, comment, subscribe to support my videos. If you did this challenge and you feel like more would be helpful, I've got a list of challenges on my website, simforge.co. You can find my tutorials, my challenges, and my games on that website. It's also a work in progress, so any critique would be very much appreciated. So without any further ado, I'll end of this, and we'll see you guys later.